Good afternoon. Hey, Adrian.
Hello.
We're back with a continuous delivery topic. It's been a while. There we go. That background will do. Shall I zoom in? Yeah, you have a new camera, don't you?
Yeah. We need a good camera when we talk about Jenkins versus GitLab. Or what is the topic? Of course, it's GitHub Actions.
Yeah, the GitHub Actions. Akash, hello.
There's a new function. It doesn't work.
We're going to talk about that. Let's just introduce the topic for today.
No, never mind. Let's go.
Substack crew is coming in. Bastian, hello. Michal, Silvio. Substack crew is here. LinkedIn crew again. The technology isn't what it used to be. Give us a life sign that everything's okay. Say hello. Where are you tuning in from? Are you listening in from work? Are you home? And Akash, as always, a new regular tuning in on YouTube. Okay, all three channels connected. Today is about continuous delivery, particularly about those, at least the three things that I find a lot that is sort of, I don't even have to ask. I know that it will be a problem in any organization that, sort of either asks that there's this sort of bridge towards we would like to do continuous delivery, but we have a lot of good reasons for why we can't or why we aren't right now. Jose, hello. Or they think they are doing continuous delivery or they're doing continuous integration, but there's like a 20% effort of what it could be, but then there's always a good excuse for why it isn't getting better. It isn't getting more continuous.
More continuous. So continuous for me is an absolute term. So either you are continuous or are you not continuous. Right. That's how I would see that. So it's not like you are 80% continuous. It's like that's still a bumpy road. Then that's not continuous. That's right. You try to be. So
we can start there. Yeah. Like how would you define the opposite of continuous delivery? Like is it discrete?
It is basically unclear when you deploy next. So it can be in 1 week, it can be in 2 weeks, maybe in 3 weeks, or even later. Maybe today. You don't know. It's a little bit like because you plan it, right? Or you're supposed to plan it, and or like in the gaming industry where it's still very prominent, where people celebrate updates. So it's basically a little bit like that one, but that's more like how you deliver to the actual clients, not necessarily how you deliver to some form of integrated thing, but never. So the idea is so what continuous delivery is not is to basically not try to be on par and integrated with your people every day and try to be in a stay in a deliverable state every day. That's for
Hmm.
me in particular how I would wrap it up. Of course, there's more to it, but if you don't have these kind of things, you're definitely not doing continuous delivery. That is how I
Hmm.
see it.
I see a lot of people tout this banner of you need to do continuous delivery because that's what Dave Farley says is the definition of modern software engineering, and then they might have watched too many uh, OTJ episodes with Brian Finster, and they sort of got convinced through his sort of brazenness and candor and charisma that if you're not doing continuous delivery, that you're doing something wrong, or you might be reading the Dory report or listening to ThoughtWorks' chief scientist Martin Fowler, and it just there is definitely a stigma that
Hmm.
if you're opposing CI/CD, like I think you get sort of written off as okay, there's something wrong in our organization. Like for example, every job ad that I see, every founders meeting that I see, when CTOs are doing due diligence, there is a mention about
Hmm.
CI/CD practices, but very rarely is it actual continuous delivery, or even continuous integration, and that
Hmm.
seems very odd to me. Like there seems to be this stigma for yeah, if you're consciously not doing it, there's something not okay, but
But
it's
this is what
very
you hear in social media, business social media. It's not necessarily what you hear in real companies. So in most real companies, I was guesting, joining them, talking a little bit about that. I basically met no one here in my local environment or area or convention, something like that, who actually practice continuous delivery by the definition of Defale. No one's
yeah,
actually doing
agreed.
that. Some are doing that in some form of similar way. Like I did that
Hmm.
for so many years before I actually knew about that.
Hmm.
But not really to the degree that, as you said, Brian Finster or Dave Farley or whoever is all going in the same direction with minimal nuances, actually. But it's actually the same idea behind that,
Yeah.
and that is what most people. I would even say most developers don't even know about those definitions.
Yeah.
That is the reality. So it doesn't mean that they don't dislike that or they don't do that by intention or not. It's simply they don't know about that. It is because they don't practice it. So you learn.
Yeah.
Most developers learn on the job.
Yeah.
Together with
I
their
did as
peers.
well. You did
And
probably.
yeah,
So
yeah,
yeah.
everyone did.
Yeah.
Especially in our times, there was no social media like today, where you could learn from outside or let you get inspiration. You would read books, right? That's it.
Hmm.
And yeah, most simply still have their pull requests, code reviews,
Hmm.
branches. Let's branch this away until we are finished. That kind of thing is the most
It's
dominant thing.
interesting,
Yeah.
you know, because we don't have a university, right? Like we don't have a there's millions and millions of software engineers in the world, yet
Mhm. There's
there
no
isn't
connection.
there isn't a like bleeding edge university out there that would teach what we would consider modern software engineering. So,
Mhm.
and I'm specifically thinking about commercial application modern software engineering in a team. I'm not talking about computer science. I'm talking about specifically modern software engineering.
Yeah, the
Uh,
practical application of
yeah,
yeah, yeah.
yeah, like working in a team and building software for like human use.
There is something in Germany which is supposed to do that, but it's simply not. So because it is not modern, that's the problem with that.
Yeah,
It is
yeah,
there's the vocational training, which is basically a form of it is like a 3 years extended boot camp with
yeah. It's not like a
theory.
university, and it's not a master's degree, but it's more like a
It's
uh,
below bachelor
technical
degree.
school. Like
It is
a
below
I don't know
technical
what.
school actually.
Yeah,
It is a very simple thing, but
yeah.
you can earn good money, so it's not a big difference. You can basically
It's
go.
more like a trade school rather than
Yeah,
yeah,
it's basically vocational training by definition. It's the old
yeah.
school apprenticeship thing
Hmm.
coined onto the
Hmm.
software development space,
Which is
and
odd because it is a very complex field, and in some aspects you can have access to like very critical critical information or critical
mm,
services, critical infrastructure. Um, Privacy is nowadays, at least in Europe, so important that it almost makes like these kind of skills non-negotiable to know how to build secure systems at the very least, or pri- or privacy compliant systems.
Yeah, but that's not a barrier in that kind of training. I actually like this kind of training, to be honest, because
Hmm.
I'm a vocational trainer, which means that I am officially allowed to teach these people. Um, and it is actually a very interesting thing. So you have everything when it comes to software development, what you would need in form of application. So how you
Hmm.
apply those
Hmm.
ideas into practical matters, the theories behind that. But in reality, most teachers are simply not capable of doing. That's the problem. That the
Yeah,
teachers themselves aren't capable of understanding what modern software engineering actually looks like. So what do you expect
I
then, right?
I like the state of JS, state of React,
Mm.
the Stack Overflow interview, the poll, and the lead dev research that there was a lead dev not interview, a lead dev poll survey
Hmm.
is the word I'm looking for. There was a lead dev survey right now, and usually one of those like less important questions that get asked in these kind of surveys is, where do you learn new skills from?
Hmm.
And top of the list is YouTube conferences bootcamp. It's not formal
I
education.
really
It's
believe that
not.
YouTube is it because you have such a variety of deep knowledge and a mixture of what you would get on Udemy, plus at the same moment a like an expert talking about these matters. On the other hand, you
Mhm.
have a lot of crap there as well. So it is, you know, there's a lot of noise, as you would say, on YouTube. That's one of those downsides. Bootcamp is a little bit like you don't learn new skills in a bootcamp. You learn the basic skills in a bootcamp, isn't it?
Yeah, it's also very targeted. It's also targeted. It's also too expensive. So it's usually assumed that you probably can't afford to go to a boot camp unless you already have a job, and there's
Uh,
probably an overlap of things that you already know and should know but don't, that boot camp offers, right? So it's sort of like a peer training rather than like a drastical sort of uplifting in skill. The modern approaches are more, coaching oriented or technical training, etc. On like a methodology. For example, there's a lot of TDD or extreme programming courses or workshops, like 2-day workshops and similar. Nick Shoemaker, our streaming partner and our good friend, he does or used to do something similar. He's also now doing like an initiative to sort of help more sort of community source this or sort of open source this kind of trainings.
but
But
to
there's very few things. I mean, other than obviously Dave Farley, where you would, like you have to go to Dave and sign up to his bootcamp or his course to learn what Dave thinks about continuous delivery.
Yeah, but in all
Um,
fairness, this is still not official. So it's not as
yeah,
official as we would know it from the medical space or something like that, where
exactly.
every doctor, every
Yeah,
pharmacist need to go through very specific
yeah.
type of training,
Hmm.
certifications, need to go to tests and approve colloquiums, all these kind of things, right? You
Yeah, we don't
don't
even
need
have
to
an
do that.
ISO standard for, continuous delivery, which is odd, considering that that would basically fit the criteria for a predictable system.
And the larger organizations like IEEE, they become a little bit unknown these days. So there is not even a large association anymore where the junior developers really look up to. So there's so much variety now instead
Hmm.
of one overarching thing. There were
Hmm.
several attempts like the IEEE thing, those kind of things in the past, but I don't see those kind of things lately. As you said, Dave Farley in form of a very dominant influencer who is with a huge, you know, chunk of credibility in that case.
Hmm.
So that's the reason why he stands so out of the crowd.
Hmm.
But he's still an individual. So of course, probably little company behind that. But you know what I mean. That's people
Yeah.
like Brian Finster supporting this idea and very loud people, which is good. But there is still no. So even though we are now sitting here and sounds a little bit like we're promoting that things like like continuous delivery, and probably extreme programming should be, let's say, the idea of modern software engineering. But you would go into a room and you would get a lot of different opinions about the idea that that should be the standard.
I think
Yeah.
if you go into a room and ask it randomly, the vast majority will not mention continuous delivery and extreme programming.
Yeah, I think
It
extreme
it
programming
it
is
it,
even
it,
more
it,
unknown
it
than
yeah,
continuous delivery.
yeah, which is odd, right? Because considering all of the at least scientifically tested and researched methodologies and procedures that we keep recommending are mostly from extreme programming.
Hmm.
Um, there
And
are alternatives, of course. So
oh, go ahead.
I wanted to jump into our agenda for today, if
Let's do that because
unless
we
you have.
already are 15 minutes in.
Okay. So the
That's
agenda,
interesting.
I picked 3 reasons that to me come up constantly. Like I don't even have to ask; they're there, and those are um, work in progress is not transparent. That's reason number one. Like there is some kind of stigmatized relationship to failure, or there's like this sort of perfectionist tendency going on in how work needs to be rolled out and done. Number two is there's tooling gatekeeping going on. So there's limited access to, I don't know, logs or access to production, or there's like there's a yes, you can be SOC 2 certified, for example, but that doesn't mean you can't have access to production. That just means that access to production needs to be logged and ideally kept to a plausible minimum. That you don't and unnecessarily like tinker with like two escalated permissions needlessly. Um, and number three, and I have to cheat because I lost my train of thought. Number three is branch based, right? So that there is this tendency. I saw Matthew Skelton talks about this. Matthew Skelton is one of the authors of Team Topologies. I saw Matthew talk a lot about this, like almost as a joke, but really as a, how many hours do your, in hours, what's the age of your feature branches, right? So it's this idea that if you have an issue with like number one, like the stigmatized making mistakes, either making mistakes is stigmatized or work in progress is being looked at as defective. It creates an environment that doesn't enable continuous learning, so people don't ask for feedback until they think it's ready. If you delay feedback until you think it's ready, you're probably not getting feedback fast enough, right? So there's this constant fear of breaking production. There is, so number one, fear of breaking production. Number two, lack of ownership between like the dev and everything else, right? It might be access to, I don't know, the credit card used for AWS, like that would be operationally extremely important, so they can maybe provision or autoscale something that they need to, or maybe they need to have log access to things that they might need to run for debugging or some live telemetry. It could also be that they might have to set up a new pipeline and certain developers don't have access to doing that, or maybe provision a new database and certain developers don't have access to doing that. So there's this sort of skill gatekeeping or infrastructural gatekeeping going on, where you might have bureaucracy involved with what devs have access to. So devs, I mean people involved in product engineering, in like the most creational aspect of product engineering. And number three, long feature branches. I think that's, these three I think are like the main cancer.
Then let's jump into the first one. Fear of
Let's jump into
breaking
the first
production.
one.
This is how you send it to me.
How did you lose your fear of breaking production? You had it at some point, right?
I just became stoic, and since something break, I don't care about that. No. So first, you need to develop. So, of course, now we can go to the definition and say you need to have this and that in place to have to build up confidence and these kind of things, specific techniques. We can talk about TDD, BDD, those kind of things, and of course drug-based development. But all these kinds of things are important. But the idea behind that is more important. So it is the idea that how you actually become confident and what confidence means. And we have talked about that quite often. And we personally, so we have multiple projects we're working on for large companies, small companies. So it's a large mixture now, but it's more and more productized. So it is even more important to not make mistakes. So, but mistakes happen.
Yeah.
The point is, you need to be confident with the possible mistakes which could occur. That's one of those points, which means that you should design the work you do in small chunks of work. That's the first thing. So you should be able, and the technique behind that is now not relevant. It is relevant that you get to the point that you have that. So when you deploy something, you need to exactly know what happens. And that there's just this last bit of chance that something could go wrong because of that. But you don't deploy something you simply don't understand anymore because it's totally overloading your mental capacity. Instead, you just go and have some changes you can oversee, maybe with a peer together, and you'd work together on one day, right, on things, and you bring them out. You know exactly what happens, which file changed, what is to expect. You have tested it. You have automation tests and those kinds in place. You know that for the next time as well, you have made it solid for the others as well, that it's understandable. You have simplified, you have refactored it to a more simple version. You have cleaned it up. You made sure that everything is to a specific set of qualities NFRs you have defined for yourself, so that you can say, okay, if now something breaks, then okay, it breaks, but it will definitely not kill the system. It is more like, oh, maybe we have a UI glitch if something goes wrong. Maybe one or two users see an error, others don't. Those kind of things. So if you are afraid that you deploy something and suddenly your application is a white or black screen, and you have that constantly, then you have a huge defect in your team and your progress. And that is what I mean by that. So if something can happen, and it's a particular thing for some users in some spaces, which happens often, it's often in a year, I would say. This is not like never. But that is a set of, let's say, of things you define for yourself you want to reach. For that, we can talk of course about specific practices and those kind of things, but it is the intention you need to get to. That's how I would define that.
You're saying there's the mindset behind it, the mentality behind it, the principle underneath it all is much more important. Like working with fallibility. We're working with the assumption that mistakes happen and sort of need to have a strategy for it rather than trying to avoid them.
Yeah, so you need to first of all, everything is contextual, but I don't like to say it depends, because it depends is the most laziest answer a developer can give. So it sounds smart, but it isn't, because it's obvious that it depends, right? So you have context, so you need to give some explanation to that in the same sentence, which is actually that when you have so imagine you are working in an agency, and you have a lot of people working in the agency, and it's mostly like change-based things for landing pages, those kind of things, right? Then the things which could break are mostly UI-specific things, but it is not very likely that things actually break in a way. So because when you have a next app, for example, Next.js React, and you start it and you see it and you deploy it, it is probably the same thing on production as you see it locally, which you have already reduced a lot of problem spaces there. But if you work on let's say, enterprise grade things, multiple services, you have a lot of contract tests in place where you have a lot of integrations from other systems which might have changed as well, and those kind of things. That is a total different story, where you need to have this other or a different set of practices, but still the same mindset. So the mindset is, or let's say the definition of, is can you confidently deploy? So the risk is simply lower for a little landing page for small companies who might not even have traffic today on that landing page, and a large system where on some point even lives can depend on. That's a huge difference, and there is so much in between, right? But the mindset is the same because it's agnostic from the actual context you work in. As soon as you are confident, which risk is a part of it, then you actually are on the part where you could go for continuous delivery or not. That's depending on how you would treat it. Right? And probably that's one of the reasons, because most developers I know in my personal space here around me, which are not me, are in agency-like companies
Yeah.
supporting the small to medium-sized area
Hmm.
in Europe, and they don't tend to practice CD in a way it's defined, but they have a little bit like something similar. It's a little bit like when they have something ready. No, it's not similar. When they have something ready, they actually deploy it. It's a little bit like they work. No, it's not. I would correct myself now. It's not even close to continuous delivery,
Mm.
because I think even though the risk is small, they are afraid of. There's another aspect I wasn't talking about. I completely ignored that one. Is that sometimes you can have bugs where specific clients of you, not the end customers, the clients, so the people you're working with, the actual
Hmm.
peers
The
on the
business
business side,
partners. Yeah.
exactly, and they see a bug, it is way more severe than actual end consumers would see, because it might not affect them that hard, but
Hmm.
people don't like to have bugs in the system because they've paid for these kind of things, and that is often the main driver to not continuously deploy. But I know that from other companies who do SaaS products, who like, if something goes wrong, then yeah, well, it goes wrong. We correct that and we become better. It is more the
Yes.
the old Facebook
Yeah.
mentality there,
Yeah.
and so because you don't face the actual end clients, it's just a
I, s-
matter, a ticket which coming. But if your actual
I'm
client on your phone
I'm
shows something
glad
to you, it's
I'm
different.
glad you mentioned Facebook because I think it really paints a good example of the principle itself. So you don't need tests to do continuous delivery. They help immensely.
Hmm.
But as you already said, the principle is more important. It's the if you're going to you can do it completely blind and not even look at production. So it's possible to do continuous delivery and you're not even looking at the software. You're just waiting for bug reports. Like you can do continuous delivery that way as well. And I have worked in environments, almost 20 years ago that have been very reminiscent of that. If you ever worked in accounting, then most accounting software is like that. Like you will know when they need it and not sooner. Um, you can do CD without tests. The tests are not a necessary component. What's important is that you need feedback of whether or not it works. And what's important is how you act in the face of receiving feedback of it not working. I think that's where the fear of breaking production um, comes from predominantly, is that you're already working under a lot of pressure.
Hmm.
If you deliver something under pressure and you break production, now you have two issues. There's the pressure of I don't know how long the fix takes, and production's broken. So there's like now two costs compounding. I need to get the fix out as soon as possible, and now my whole process is disrupted, and something's not okay on production. And I think I'm confident that every developer who has seen like the full cost of owning software, of owning software systems, especially like seeing from like the business perspective what it takes to like finance, cloud operations and having a software, these things go away, the fear goes away when you understand the risks involved and the costs involved with keeping the bug state. For example, I used to work in systems that had like strict closing hours,
Hmm.
where it was like high traffic, high traffic, high traffic, high traffic, high
Nothing,
traffic,
yeah.
and then zero.
Okay.
And I was extremely
Hmm.
confident deploying to production in those low traffic hours, right? Without tests, because I knew that the cost of breaking production was zero, right? But I had to understand that to not fear it. And then I went from that. I worked in advertising, and then I went from that, and I suggested, hey, like I can deploy fearlessly if I know that I'm in that situation. If I know that the campaign is not running in that region, I know that I can do an experimental deployment.
Hmm.
And then I just said, hey, what would it take for me to get that mentality, to get that power all the time, 24/7 on all systems, right? And that's when we started doing canary deployments. It's like I have a server, right, where I control how much traffic goes to it, and I can use that as my feedback mechanism, right? So I have a universal feedback mechanism because I don't have a lot of tests, because it's a complex system. It's a very old, very sort of, most of the side effects are in the relationships between the systems, not in the systems themselves, which makes it extremely annoying to sort of test.
That makes it so hard to test those very scattered systems over several
So we
services.
had like a very complex Hadoop pipeline that only ran on one machine because it required 8 terabytes of hard drive back then and like extreme amounts of memory. We only have one of those. We only had one production grade one. And several other systems that are working in like different infrastructures that are through load balancers, and you need the real thing to sort of experience the whole life cycle. Isolation back then was not something we focused on too much, and Facebook operated like that. Like Facebook just operated on this level of like, it's so easy to get feedback, safe feedback, and if you break something, to undo that in an isolated manner, that like, not having tests is not an excuse for leaving something on your local machine. Like, it needs to go out to production. Like the priorities will change, your attitude will change, the fear will change, the scope will change when you show it and you test it in the real environment. That's not to say that you can just build lousy code and crash production, and like there still is some level of rigor. It is not the last line. It is not the first line of defense. There are other things than that compound the safety of this.
I think maturity itself, so it does fit to the first point as well, is the maturity level overall of the team. So if you have, let's say, a team of 3 developers who are very experienced, they know each other, they know the style of each other, they know the conventions they have built up, and they know in the moment, then when I create now a new function, new class, new component, new service, something like that, it's standalone, it doesn't touch anything else, then nothing will break except maybe this one. But you can see that I've maybe changed something which is hooked into many other things, right? Then I need to have more eyes on that and have maybe the manual test after production. If there is not a side effect I maybe have not seen, or even tests in place which don't cover those things. That is something a mature team knows, it's risk management. Can I deploy that without thinking? You're not even looking at production without tests. You can do that in many cases, but in some cases you definitely need to do even manual tests. That's how I do, even when we have tests in place. And I even often test things myself, which are so complicated in some apps we do. I really mean that. They are so complicated that you even don't really understand them, why you develop these things. And you are happy after a day to understand and have good result there. You have refined that, you have simplified that, but you are there was so much going on this day on this very complex thing, especially in legacy systems. And it is always good to take a quick look after the deployment. Are things running? That doesn't take away from your confidence. It even adds to that. So if you can deploy, you see it's green. I see that in our pipeline, it's green. I'll take a look at live. Most often the test is so quick. You just go there, click 2-3 things, and oh, it's working. Okay, nice. Next thing. And that's how we practice that. Do we need to do that? Most of the cases we don't, but I still do that because I want to have a feedback for myself, the very first feedback, what happened after the deployment. I still do that, even though we don't need to do that. But mostly because we do work on front end as well, and so not me as a person, I as a person do that. And there is one thing, when you run a complex application in production, it runs differently than in development, and you want to quickly get the feedback of, is it actually performing the same way like you do it. So locally on your nice ARM laptop, right, you can run Docker very fast, while Kubernetes in the cloud isn't that fast. That's one of those things. So maybe it's different there, those kind of things. You want to get some feedback how those things work.
One of the aspects of fear comes down to, you don't need tests, you need feedback, and you need feedback quickly and frequently. Tests just happen to be one of the easiest ways of getting feedback, of maintaining a sort of rigor for feedback. It's not the cheapest. Like, it takes effort to build good tests.
Yeah.
And if nothing else, if you're building end-to-end tests or integration tests primarily, if you're sort of avoiding the effort of building unit tests because you might not be doing TDD or something similar, you still need to deploy to production to see if your assumptions about your test sandbox, about your integration sandbox, whether they were realistic enough to actually stand up with scrutiny to your real production environment. Because there's nothing worse than just seeing your test be green and then you deploy to production thinking that everything's okay, and then you still have, right? And then you still break production. So you had a mechanism to sort of alleviate the fear, and then it gives you a false positive. And then not only is it, there's still a risk of breaking something in production, but also now you don't trust the thing you invested time into. There's that aspect. So definitely feedback very, very, very early. We could be building the wrong thing. We could be building it the wrong way. We might be wrong about some base assumptions. Once you have something that is ready, that is like ready to be deployed or reasonable to be deployed, just get it out. If you have to feature flag it. The second aspect is I think has to do with feature flags. Is I see a lot of self-imposed stigma from engineers, just engineers, regardless of whether they're doing continuous delivery or not in their organization, is they don't want to share work in progress. And you see this a lot from senior directors of engineering, from Stripe, from GitLab, GitHub, Netflix. The CTO, Netflix's CTO, is very adamant about this, about the psychological safety aspect of not only encouraging but requiring people to work out in the open. Right? So there is no stage that says it's on my machine, and when I feel I'm ready, I will commit and I will push. It's constantly pushed. Like, all of your work in progress is constantly available to other engineers. I think that is a very important, possibly the most important aspect of maturity for an engineering team, is that there isn't this, I make a mess and I have my mess in my workspace, and until I'm happy with that, I'm not showing it to anybody. Versus this mentality of, no. Like, we don't allow code to be built in a messy workspace. If you want a messy workspace, you don't work here. Like, we run a clean kitchen. We don't make a mess while we're cooking something. Right? So it's that aspect of, some engineers find it invasive. Some engineers find that of, no, I have my own way of, I feel comfortable building software in a certain way. But then, all those problems creep up. It's like, yeah, but you left a mess. Like, hey, you have to go. Like, something came up, you have to go commit. Like, share it with your team. Like, we can review it while you're gone. Like, you need to pick up the kids from daycare. Good, go. But commit the code. Oh, it's not ready. Right? I'm not happy with it. I'm working in a mess, generally. And I haven't converted it from messy to not messy.
I often, when people, we had that discussion very often in mentorings and these kind of things. I like to use the metaphor of climbing, even though I'm not a climber. But when you climb, you have those nails you put into the wall, right? That's the security nail, or hooks. You put that in, and that is you can have that as well. You work your code towards that point where you are safe to release. Your code compiles.
What is it called? It has a name.
Pitten? I don't know. Pitten, I think. I'm not sure. But you know what I mean. It's a little bit like you work. You don't just do the entire feature in one go. You do it in step by step from those hook or pitten to the next one, and that is a good way how you can release, or sorry, not release, how you can commit and push something even though it's not finished. But as long as it doesn't break anything, right? Maybe it's toggled out. That's the easiest thing you can do. If you build something entirely new, you can just, the first thing you implement is the toggle for that, and you shut it down, and you only have it via environment variable or feature toggle, something like that, toggled in on your machine, and you just make
or a
sure
config. Like, we have configs. Yeah.
It's the same thing, right? It's a form of conflict somewhere,
Yeah.
and you don't make you prevent that this feature even does anything.
Yeah.
And when you do it, as I said, in a mature way, and you know, okay, this feature doesn't change anything from utility functions, that something like that,
Hmm.
then I don't need to worry. And if I
Yeah.
worry, I still can ask a peer, hey, could you quickly come over and we make a pairing session or a review session? Can
Yeah.
I have your pair of eyes? Then it's done as well. Don't just push it. That's integrated.
Yeah. It's much
Get that
easier to
results.
test things when you say, I merged it, it compiles, it builds, it doesn't have any unknown side effects when it turns off, which is a very good sign already. And when you do turn off, it is limited to like this context, to this scope. It's very easy to then build it, push it to production, and then somebody for themselves flips the feature flag on their own account and tests it. And maybe not even tests it, just maybe does a taste test. Like, is it tasteful enough? Like, is it too soon to deploy? And you would want that. You would want it delivered sooner than you're comfortable with, so that somebody other than yourself can see and say, yeah, like, we're not there yet, but it's not bad. It's not as bad as we thought. This is actually really close. It might need just a little bit of polish, not like a full-blown redesign. When it comes to front-end stuff, of course. But it might be other. It might be other. Well, what's
That was the word. I was just pronouncing it probably incorrectly. It's Python. I don't know. How is
Okay.
it spelled? Python?
I don't know. Isn't it CAMS?
Where are British people when you need them?
Okay.
Second topic?
Part 2. Yes. So lack of shared ownership. I think shared ownership usually comes in that there's generally a human gate. So not a feature flag, a feature gate, but an actual human. In environments where this is a problem, which is almost everywhere, there is a certain level of like a key maker or a gatekeeper or a key master who holds certain elevated security privileges to mundane stuff, to like very boring tools, right? So, for example, any kind of observability, telemetry, any kind of monitoring, adding new monitoring logs, getting fresh logs, canary deployments, changing the pipeline, spinning up a second pipeline, turning on or turning off merge permissions on certain branches. And then there's the whole SDLC gatekeeping, right? So the tool-based gatekeeping where there's this sort of artificial, we have a Kanban board, and then there's a process how to transition a ticket from this to that, and then you need to click on this Jira tick, right? So it's just friction created by bureaucracy that prevents you from sort of moving things forward. It's like, no, when you put it in QA, you can no longer change it because we need to know what revision we're and that sort of that hand-off mentality, like throwing it over the wall mentality, it sort of creates this sort of impediment of there are some like feature freeze expectations here, or there might be some rigor expectations of somebody is doing some kind of like manual slow process with your deliverable, and now you're isolated from making changes, right? Either it is a human blocking path to production, or there's a tool blocking path to production, and the tool requires multiple humans to sort of do a ritual of some kind. The way I have seen this, like the biggest dysfunction that I've seen is you commit something, you open a PR, it requires 3 reviewers, one of them has to be a senior for every PR that you open. PRs are the only way to merge something to the trunk, and you don't communicate with these people directly. Like you need to hunt them down and get their approval, and sometimes it's just like very benign. Like it's having to sort of create a meeting every time you want to deploy, even though the deployment process is automated. That's let's say the biggest type of dysfunction. And there are many variations of this. It might be that the deployment process has 2 steps. Maybe they have this equivalent in QA. Maybe you have this equivalent on front end, or maybe there's this sort of batching going on of the backend stuff is done. It can go out to production, but let's not roll it out needlessly. Let's wait for the front end guys to catch up and then maybe do it together. And that sort of batching, there is also this sort of human gating of no, like if it can be done in parallel, do it in parallel. It can also be that your pipeline is configured weirdly. Most pipelines that I see, GitHub Actions, Jenkins, I think without ever being scrutinized, nobody optimized the pipelines. Because usually what I see is style linter for PR, linter for code, formatter for code, build, package, try to deploy to staging, run tests, and then there's certain combinations of unit tests, integration tests, tests on staging, acceptance tests. And then there's maybe a build artifact being built that is production ready. And then you maybe have an automated deploy in that pipeline if everything's okay, if you're doing continuous deployment as well. There might be some signature signing going on of the build artifacts. There might be some canary deployments going on. There might be a sort of Slack message sent out to somebody if something is wrong. And usually that's a very inefficient pipeline to set up, because what you would want in like the tool is for the developer to say, the linter I can run manually, so the linter should never block the other processes, right? So that's one of the things that is like very difficult to explain to people, but it's basically just pipeline optimization. I want to run the thing that is most likely to fail first. And usually the tests and the tests and the integration tests and the end-to-end tests are more likely to fail. And you want to start running the slowest process first, right? So you don't want to wait for the linter to finish, or like as soon as it is built, just start running the end-to-end tests. Even if you're not going to deploy it to production because of the linter failure, the end-to-end tests are the slowest to run. So you want that feedback as soon as possible, especially if they take like 10 minutes to run. Especially nowadays, if you're doing like some kind of AI analysis on top of it, or if you're doing this procedure on a pre-merge hook on like pull request candidates, or if you're doing trunk-based development and there's sort of like some kind of gatekeeping going on and going on a privileged release branch, there's way too much time being lost on just linear pipelines that could be parallelized and made simpler. And engineers just don't have access to change the pipeline, to optimize the pipeline.
How would you improve these things? So we've talked about now a lot of problem cases. There are a vast, there are a lot more, let's say. But what can we do to actually improve that?
The collaboration or the pipeline specifically?
The topic was the lack of shared ownership between dev and ops.
I think pairing is one of the best solutions here, right? So you don't want to do this sort of handoff mentality of once I'm done with coding, it becomes your problem. What I generally recommend is in organizations that have few steps, I would say whoever picks up the ticket has to make sure it gets deployed.
Yeah, the full way,
right?
All the way.
Yeah, so if there's a QA problem with it, like it's the engineer's responsibility to make sure it goes through QA quickly. Even if they're not involved, like it's their responsibility. It's like, hey, yes, there's a QA gate. It's your work. If your work is being blocked by QA, you have full control. Like if QA is busy, build your own QA team. I like that. That's how I would approach it.
Yeah,
and then empower them.
Yeah. Then so we even go that far that when we do something for clients in specific, as in particular, we even talk to those, right? When there are changes which affect their doing, or they want to know about that, we're going through that and get direct feedback from them. Each developer who is involved, and that is, when sometimes backend is even pushing things out before front end, something like that. It's even on production. So unused APIs, I would call them. And as soon as the front-end team then catches up, right? Then you basically then have the feature, which is most often the reason why the front-end people are communicating more with the clients than actually back-end people.
Yeah, that's fair. That's
It's
fair.
the visible
And they, and
part.
they, they also have like an ulterior motive of part of their feedback that they're looking for is feedback of taste.
Mm-hmm.
And that is very difficult to automate. So you would want to, like do a taste test with a human to like verify like the look and feel, let's say, of the UX
I
of
do that very often when I have
yeah.
prototypes. Then we have that from the
Yeah.
SaaS application
Now
we're
I
building
also do
right now.
that for backend stuff, right? Like if I'm building a new pipeline or a new, if I'm teaching a team how to run tests, I would definitely run a taste test with them. It's like, is this kind of test sensible for you guys, right? Because there's many different variations of how we can do it. We can do it data-based, where we can just
Early
have
feedback.
a lot of
Very
snapshot
early
tests and just a
feedback.
lot of examples, or we can say, okay, let's go hexagonal. You guys like hexagonal? Let's create simple collaborators and let's categorize them for, UI facing collaborators and persistence facing collaborators, and that covers 99%. Do you guys want to do that? Like, is that in good taste for your ecosystem, for your product, right? So I would definitely like that's DX, right? That's developer experience. Sometimes there's just a lot of manual work, and I would just sit down like somebody, an SRE or a DevOps engineer, whatever that means, and the software engineer, and just tell them, hey, like, look, there's a checklist. The checklist has you running 7 commands in sequence. Like, can you turn that into a script and then, get feedback from each other and iterate on it like for 2 days, and then we see if that makes everybody's life easier. That's how I'd approach it. But I would approach it more from this idea of, I'm not going to tell you to do this. I would much rather you hold yourself accountable to doing this. Right? So if I have to ask you to do it, there's already a problem. Right? So if there's something causing friction in how you work and you don't take care of it, the fact that I have to ask you is already something that, is a sign that, okay, like why did I have to speak up? Why didn't you just go and fix it? Right? So for example, if I'm, consulting, like standing in as like a staff engineer or an engineering manager in a team, if I have to ask them to refactor something, there's definitely something not okay, right? Because they're waiting for permission to refactor. Or the other way around, they just want to continuously refactor, which I think is more common, which is just they just want to, they're just always unhappy and they just want to continuously refactor everything, and I have to slow them down. It's like, why am I gatekeeping here? It's like, you guys want to refactor? Sure. If you refactor endlessly, you'll be delayed on your deliverables. Like, there will be
Don't refactor
consequences.
for the sake of refactoring.
Yeah, refactoring for the sake of refactoring, because it is an endless activity, right? And they
It
might
can
do
be.
that.
It can even be procrastination.
Yeah,
if,
but
if you
it can
make
be
that for fun.
it can be procrastination because they are siloed and they don't see the cost of delay in operations. They don't know what the cost of missing the deadline is. They might not know that there's a marketing team waiting here for like some updates, and if there's like a bad relationship between operations and the software being built, they might have a very skewed idea of how they think they should be prioritizing, and it's not their fault. But like, they need to be brought together. Ownership is the new black, Callaghan says. We already had a restaurant analogy, so welcome. It's good to see you again.
It's a very late LinkedIn comment, which was
The LinkedIn
transmitted.
API for StreamYard, there is like legit delay. I don't know why. I noticed it last week as well. Thomas had some questions on Substack for you, but that's more about you being able to have apprentices. That was sort of slightly off topic from what we were talking about earlier.
Yeah, but Thomas, you can reach out to me via LinkedIn
Yeah.
about that.
Yeah. What else? Is there anything that stands out to you regarding shared ownership? Like, how do you handle it? Like, from as a business owner, how do you spot? What's a
I
litmus test of?
always the the culture requirement of maturity. So everyone, even a junior developer, should be and must be enabled to go all the way from A to B, the entire journey, every time
Yeah.
anew. And everyone should learn early on when you can do that on yourself. So risk management, it's up to you. It's your ownership.
Yeah.
It's your responsibility. And on some point, your accountability as well. But we try to keep it blameless. So if something happens in good faith, then nothing happens. But it is that way. So keep the process that simple and let's say the ownership that clear, that it's easy to take in the responsibility, but you actually can ship a small feature continuously multiple times a day. That's actually how it works. You don't need to ship continuously, so continuous deployment is not a must at us. So we don't actually deploy every day because sometimes we simply so the focus is still on the integration and collaboration. So we want to create better software, and sometimes we show staging to a client before it actually goes live because the clients want to have it like that. But it is like at least, let's say at latest every second day. But every developer must, so as soon as you touch something, you are basically responsible for that. And that is, I think, the key in general, to keep it extremely simple. I don't know if that actually works in extremely large corporations. I never tested it there myself.
It doesn't work. So there's friction. I've seen this before. I mentioned earlier, there's two examples. In organizations where there's few steps, imagine a Kanban board, like a Azure DevOps pipeline with few columns. That works. Sometimes there's like many, for example, you might be building software for a car, and not only do you have to build the software for a car, but it also affects how maintenance for that car is done and how that car is being manufactured, and how that car is
software development.
So there's the pipeline of the software, there's the pipeline of the machine where the software goes into, and the delivery mechanism of the machine, and the maintenance mechanism and the maintenance lifecycle of the machine. And you have equivalents of this in meditech, in biotech, insurance, right? Where there's a level of maybe jurisdictional delay, or like a contract on the timeline, where yes, I can update the software, but if there's a mistake, there's like some side effect to reversing. Like reversing has a paper trail, and we want to minimize those. You had this in fintech. I think it was in accounting in general is one of the most frequent examples of this kind of system, where there might be many steps involved. That doesn't mean it's impossible, but because there's many steps involved, you would want to have continuous deployment, continuous delivery more than in a simpler system, just because the amount of time you save by automating a lot of those steps is enormous if your process is very inefficient, right? So that just means that the friction of adoption is on a sort of bigger learning curve, because you need to basically wrangle all of the issues, and you need to take care of more things. So the friction is bigger, but it's not impossible. But the payoff is also much bigger, right? So it is like higher risk, higher reward kind of environment if your organization is very complex or just very messy. Sometimes there's too many columns needlessly. You think that, okay, we need regulatory oversight and we need all these columns, and sometimes that's just self-imposed. In those environments, the issue is higher up. It's like, why do we think this is helping? Security gates or something like review. It's like, oh, this is a secure system, we need to review. Well, why aren't you pair programming? Like, why is the quality happening? Like low quality development, low quality review.
That's a quality issue in general. So
low quality testing, and then when it's time to deploy, then the quality kicks in.
The problem is very often that
work.
the engineers don't know the quality they're developing for, and then you need to have a QA afterwards, which takes a look for the quality, which was never defined. If you define qualities as they meant to be also, before, and then it is less likely that you actually have a quality issue.
You don't even need to define the quality. Sometimes it's easier to define the budget for mistakes. It's like, how many mistakes can we afford per cycle, per week? And you might actually want to spend that budget of, oh yeah, we can have this amount of downtime this week. It's like, okay, let's spend it. Like, I have a really important experiment to run. I could test it, but it will take a week, or I can spend my experimentation budget and we'll be down for 10 minutes on Saturday, but I will learn a lot faster. Right? When you have a budget for mistakes, when you have a budget for downtime, or have a budget for, I don't know, maybe reversing a deployment is expensive. But you might have a budget for that. It's like, yeah, like it's expensive. We don't want to do it needlessly, but we can do it if it helps us achieve our goals faster. For example, in avionics and the space industry, you have this. It's like, well, you don't have, like, you have to launch the rocket and you have to see it explode, because you want to learn how many different ways are there that it can explode, and how do we deal with each one of those ways.
So,
Right?
but what I would like to add, which is I think very agnostic regarding the company size, is that you should know yourself when to speak to other people before you actually deploy something, when you are responsible for that. What I mean by that is, if you deploy a new feature to an entire system where so many other things are involved, then you probably you need to talk to the other people. At least I would do that when there is something I'm not 100% sure about.
I would actually
am I
just filter
100%
that.
sure, right?
I would just filter that. Like, I would even say you don't need to be 100% sure. This goes back to that Facebook mentality of, oh yeah, everything you need testing.
Okay, rephrase that to the initial thing of 100% confident.
Yeah, so you don't need to be 100% confident. So I like using Amazon's framework for how to do high-level decisions. It's a door. Is the door a two-way door or a one-way door, right? So is it cheap to reverse, right? So if it's cheap to reverse, let's just run it and let's run an experiment. And if it doesn't pan out, let's reverse it.
Yeah.
Right. So this level of scrutiny for perfectionism is only necessary for one-way doors, for decisions that are irreversible. For example, making a very destructive change in, let's say, your SQL schema, right, where it significantly changed the schema, and there is data loss in the conversion.
Yes,
and it is only one way. It is, for example, if you're hashing something in your schema update, it is impossible to unhash it, right? So it might be a one-way operation. Now, when it comes to these like shared ownership issues, the biggest culprit for like this fear in the first point that we mentioned is that sometimes, very frequently, most decisions are reversible, but the deploy button is in the dev team's ownership, and the reverse button is in the ops team's ownership. And they don't understand the trade-off. They don't understand hey, can you reverse this real quick? It's like, yes, but this is meant for emergencies. This is not an emergency. Why? Like, how? Why? And then it quickly devolves into this sort of shame mentality or blame mentality of, oh, devs messed it up again. I have to do extra work again. And again, especially if you're under pressure and you sort of have, it just becomes unexpected, unplanned work for the ops team, right? So yes, you can be very loose and very lenient and have tests and have experiments and have a budget for it, and can do reversible decisions on like a canary setup. And then if there's an issue, you can reverse it. But the person running the experiment has to have the button for reversing it, their decision. Like, it's annoying if you tell me, oh yeah, just run the experiment. It's safe to get it wrong if it's benign. And I don't need the meeting to run the experiment, but I need a meeting to stop it. Like, that's annoying, right? Because then if there's a fire, I can start the fire, no problem. But to stop the fire, I need a meeting. And then how people solve that is they say, all fires need a meeting, right? And that's the wrong solution. That's the wrong solution. The solution is, no. Undoing the fire shouldn't require a meeting, right? Like, we should, if we have a hotfix procedure, it's the hotfix procedure that should be available to everybody, not this like weird gatekeeping, and then there's like a really efficient continuous delivery process for hotfixing.
You need to ask for if you're allowed to fix the issue, which is causing problems right now.
I don't know who it was. Was it Brian Finster or was it Andrea Lafoggia? This idea that, oh, we have like a very rigorous, very complex deployment pipeline set up for ops and hotfix. And if there's an emergency, we're using this one, right? So there's a high quality, slow procedure and a low quality fast procedure for emergencies. And in emergency, you're gonna use the bad one, right? Because it's fast, right? So that's the main dysfunction. It's like, no, like how fast it is part of the quality. If it like creates an illusion that it's safe because it's slow, you probably don't want to use that process. I usually ask people when I sometimes coach a team like this, and I tell them, okay, cool, that was a good example. It's feature flagged. Let's deploy it. And I see them wince. I see, ooh, but that requires this. And it's like, do you have a hotfix procedure? Oh yeah, we do. Okay, let's use that one. And they do it, and I hear them. It's like, and it's that mentality of, look, if you have a hotfix procedure and it's fast, it's probably much better than whatever you're doing else. Because if you need a hotfix procedure, there's probably a bunch of things wrong with the slow rollout process. Especially if I'm training them in TDD or anything else. Should we go to the third point?
Exactly.
Yeah.
Branch-based development with late integration.
I think we got into this, segued it directly, right? So the lack of ops, the lack of reversibility, it creates this sort of backlog of things that are going out. Let's have a meeting before it goes out. So the things that have to go out has to be staged somewhere. That staging usually happens on a release branch, or just they're being parked somewhere, right? So whenever there's waiting, whenever your release pipeline is not continuous, and it won't be continuous if you're afraid of breaking production, or if you don't have access to the undo button, if the change is benign, if it's a two-way decision that can be benignly undone, then you will not roll out things continuously. And when things aren't rolled out continuously, all features that are ready to be rolled out have to be parked somewhere. And usually that parking mechanism, we call the parking lot, is what we call feature branches. And I like to use this metric of, when I see this as a consultant, as a coach, I always ask, what's the average age? Right? And they say, oh, I don't know exactly. And I tell them, is it more than 15 minutes? And they look at me funny. It's like, what do you mean? Is it more than 15 minutes? Because that's like, if I have red and green, below 15 minutes is green, above 15 minutes is red.
It's making cheese.
Yeah. And they're like, what do you mean? All of our PRs are at least 1 week. Like all of our, 15 minutes? Like it's just, it's like a week minimum. Like, what? Like that's not a helpful metric, because then everything's red. And I'm like, yeah, that's a good point. Why is everything red? Right. And then there's also the element of candor and scrutiny of, it's like, yeah, like at a certain point, like what the problem is. You have like long-lived feature branches and they marinate. And when there's work done, instead of the responsible person making sure it gets deployed to production, they start working on something else. And they might be incentivized to behave like this unconsciously in some kind of planning meeting or sprint meeting or meeting with a product owner, or with a very charismatic or bullish, or like a hippo, like the highest, what is it? The opinion of the highest paid person in the room. Is it hippo? Is it?
It's hippo, yeah.
Yeah. Highest income person's opinion. Right. So it's this mentality of, if we need to park certain decisions, if there's like feature branching going on, then we value putting more stuff into the parking lot more than clearing it. And it creates a sort of negative feedback loop of, we are super successful if we have more things in the parking lot. Right? Think of it purely from and it creates this feature factory mentality, right? Like you have two factories, delivery trucks come in, one factory has 10 things, the other factory has 100 things. Who do you think is most successful, just based on aesthetics. Of course, the factory that did 100 things, that they need more trucks to deliver things, right?
Well,
But
it depends in the inventory or on the delivery space, right? So when
yeah,
you get everything out, it's good to have to have a lot, right? That
yeah,
looks like you have good business, but you shouldn't have that on stock and you just give one of those packages out.
yeah. I see a
That's
lot of
not good.
I see a lot of sort of this sort of bravado mentality going on. Is that the engineers use self-deprecating language that where they think they're not enough as a person, like we need more, 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 and then the more tickets they move from one column to the other in a sprint, the more they feel that they're, closer to that goal. But of course, they can never reach that goal because it's an endless game. It's an infinite game. Um, but it also creates this stigma that no, I don't want the pipeline to be pretty. I want the pipeline to be empty. Because if the pipeline is empty, that means that there was no waiting for feedback. Right? I built something, I deployed it, and I got feedback, and if it's okay, I build the next thing. If there's inventory happening, then I build something, I don't get feedback. There might be something wrong with it, but I just don't know. Because I don't know, I go to the place where there is more confidence, where there's more knowledge, which is the next feature. Now you have two problems. Now you have two features that don't have feedback, and then at a certain point somebody decides to release. And even worse, once they do release, if there's an issue, 99% of the release is green, and there's one issue. And now we need to make a judgment call. When there's one issue, do we mark the entire release defective or just some subpart of it? And because it creates this issue of, are they two-way decisions or one-way decisions? If it's a two-way decision, it's easily reversed. But if the batch was too large, if you roll out everything at once, then I can't reverse the mistake without also reversing all of those other features that don't have a problem. And it creates this issue that it makes reversible benign bugs a bigger problem than they need to be, because they cannot easily be pulled off of production. They have to be fixed, right? So because the quickest response time to a bug is just, well, pull the commit that caused the bug. If you can detect it immediately, right? Like you added a commit, yeah, it caused the bug, good, deploy, not good, pull it, and then fix it if you realize that fixing it takes more time than pulling it. But if you're batching releases together, then you can only pull the entire release because you don't know which commit was stable. You don't know which commit between last release and this release. There's 100 commits in there. You don't know which one is stable. So it's pulling it and then retesting some like weird, like dynamic artifact without that commit then requires probably more work than just actually fixing the bug. And then that requires a meeting, and that requires triage. And that's basically, it creates this sort of hero mentality of, we caused the problem, whose fault was it? There's now unplanned work, people aren't happy. So people tend to be more unhappy than happy, right? So it's like it's another lever for negative emotion that makes people like dissatisfied at
They
work.
have something to say about that. So I had that lately in a governmental project where we were supporting, and with guidance and all these kind of things, and we were trying to prepare that company for exactly that, to get into that flow where you can take this ownership and have it in a flow, have an empty pipeline, be able to react to feedback, to all these kind of things when you release. Because there was this release on some day, and there was the world post-release and pre-release. And pre-release, the entire culture was a happy culture, even though they don't. It was very hard to convince the people to actually implement these kind of things, and so it wasn't implemented 100%. And the problem was that as soon as we had the post-release stage, things went a little bit sideways. So it wasn't wrong, but the culture went sideways. It was a little bit like the pipeline wasn't empty. There were more fixes coming in than features out, and features needed to be get out because they were like promised things, but not
the
yet
features
there.
were planned and promised in absence of things going wrong in the future.
Exactly.
Like that's the main
so
issue.
it became a very stressful environment to work in.
Yeah, of
And
course.
there was suddenly these typical cultural problems. I'm always talking about those. They're coming up. So there is a distinct thing. As soon as you have real stakes, real stakeholders, all these kind of things. Right? So there's more risk when you actually deploy something to real production or a production which is not yet in production, and
Yeah.
that's something very often where people think, actually we are working fine, but you are not deploying right now to real clients. That's a different story, and you should
Mm-hmm.
use this time to prepare yourself for the time post release or first release, right? That is what I wanted to give there as well, because many fail already in the time where they could train
Mm-hmm.
themselves and implement those practices,
What
get their
wh-
experience with those.
what lesson did you take from that experience?
That you should have two lessons that you actually should do that as early as you can in
So
make that
that
a part of the
do
culture
do
practice side.
do what? Do what exactly? When you say do that, like
Okay,
do
the
what?
things we've discussed today regarding continuous
Mm-hmm.
delivery to stay in a flow, create this mature workflow where a developer is able and
So
capable.
full path to
Yeah,
production,
exactly.
like a single person responsible,
Actually,
ideally the
chunk-based development,
developer.
these kind of
Strong based,
things.
yeah, exactly, exactly.
100%,
Yeah,
the confidence part, all these
yeah.
kind of things, have that in place that you can, when things become stressful, that you can react as a team very fast and confident and not
Mm-hmm.
blaming each other, focusing on the problem, and then
Mm-hmm.
not suddenly break in. And the other thing was that you need to, as a coach or a mentor, you need to make this very, very clear in the beginning what the consequences are. We didn't do, it was more kind of, no, it was not a full-time thing, right? But you should, when you do that, in my opinion, you should,
Mm-hmm.
no matter if you are a leadership person, management person, whoever is doing that, a coach, a technical trainer, you should make people clear what the consequences are and what the shift will be in the
Mm-hmm.
future. That is extremely important, because if you don't make that clear, people will, see that themselves when it's too late. And that is very often the case. You need to work on convincing people, and that's probably
Mm-hmm.
what many people do on
Yeah,
LinkedIn as well, when they openly try to convince people of these practices. We do so as well here with that show.
of
And
course.
that it is true that there is a true reason to that, because there is no slow and safe way to create software.
Exactly, exactly.
It is an illusion. You
Yeah.
say that very often, and it's very true. It is in reality just an illusion. As soon as you take away your capability and ability to react and act at the same moment, depending on what you need right
Mm-hmm.
now, and you basically force yourself into a position, or put yourself into a position where you can only react, and that very slowly will create, even it is a downward spiral into hell. You don't want to be there. Getting
If
out of there is way more painful than
if you're interested in like the
getting into it.
philosophy of this, like you and our viewers, there is a concept called the Kinefin framework, which basically simplifies these operations into like 5 quadrants.
How's it called?
Um, Kinefin, Cynefin. It's spelled Cynefin, right?
Okay,
So
let
they,
me
they
look it up.
basically go, there's the simplest quadrant is confusion. You have no idea. You don't even know what quadrant you're in. But then there's the clear, or the simple, complicated, complex, and chaotic. You probably heard this terminology before. And
It's a Welsh word.
it's a Welsh word. Interesting. I didn't even know that. And it has to do with, in simple operations, there is a best practice, right? So if you're in the simple quadrant, if you know that you're in the simple quadrant, for example, authentication, there is a best practice for authentication.
Mhm.
There is a best practice for secure exchange of secrets. There is a best practice for sending you an email. Like, how does the protocol exchange happen? Um, then there's the complicated domain, which is there isn't a best practice. That there isn't any practice that is obviously the right solution, right? So you can't map out the correct answer, but there are a bunch of good practices. There are a bunch of there are a bunch of um, um, solutions that might be worthwhile checking. So you can still use your senses. You can still use your brain compared to the simple domain. The simple domain has a solution. It's basically look at the problem, go find a book. Yes. So the acronyms SCR are sense, categorize, respond. A is analyze. And then in the chaotic quadrant, the A is different. It's act. I do have to. I have seen this picture before. The A. There are two different A's. I just want to mention that. It's called Cynefin framework. CYNFIN. Adrian just posted it into YouTube. So what happens is, if you're in the simple domain, you basically say, "What's my problem? Okay, that's my problem." You go pick a book of best practices. You look up the solution in the book, and you apply the solution. That's when you're in the simple domain, right? And the simple domain is where AI tools are very unlikely to hallucinate, right? In the simple domain, the solution can be looked up, and you can just ask the AI, "Hey, I need a conflict. I have it solved here in Python. Can you write it in JavaScript?" Sure, no problem. And it will do so without mistake, and it will probably do it much better than you do. Then there's the complicated stuff, and just the top right here, which is it changes the categorize to analyze. So the correct answer is not clear. There isn't an objective one answer, but there might be a range of answers, and you still have to sort of pick. You might have to try one thing or a second thing, or through experience, you will notice that, oh, actually, that one would have been a better, in hindsight, that one would have been a better solution than the other one. So there are a bunch of good practices, and so what stands out in the complicated domain is that there are a bunch of obviously bad solutions, but it leaves more than one thing on the table, right? So then you have a sort of, either it's nuance or taste, or maybe just culture that has you pick one solution over the other, which is, picking a car for yourself for personal usage. That might be a complicated problem, not a simple one, right? If you're in a communist state, it's a simple one because there's no choice, right? There is, what do you need? Okay, that one, and there's a book, right? Then there's the complex one, which is top right, and the decision-making mechanism changes, right? Because you can no longer you can't even look at the problem. The problem isn't clear. It's not clear what the problem is, where it is caused. You usually have this, and you if you heard the terminology complex systems, that's what we talk about. The effect that is valuable comes from the relationship, the coupling of the system, not from the parts. Like the complicated and the simple stuff is usually there's a small unit, the problem is inside there. I can look at the problem and I can say, that's a unit testing territory. Then there's the complex domains, which is emergent behavior and also requires emergent practice. So the way you solve problems is you say, well, I can't just look at the problem. I need to poke the system to elicit a response. This is your typical, in software engineering, this is your typical observability pipeline. It's like, we have a complex bug. Okay, what do we do? How do we solve it? We don't solve it. We add more logs. We go in with a hypothesis and we say, well, we don't know this. We don't have a framework for asking our system.
We need to get closer to find the solution. Yeah.
Yes, we don't have a framework for asking our system complex questions while it is in operation. So we need to probe it. We need to put in stuff that allows us more insight into what's going on in the system, right?
Typical legacy problem. When you need to fix a bug in a legacy system, you
don't fix it.
You ask for a map of the topology of where the servers are actually. Something like that.
And you can tell a junior engineer would treat a complex problem like a simple one. They would eyeball the problem until they would try to look for it on Stack Overflow until a solution presented itself.
That's what AI is always failing when you try.
And that kind of engineer would be hallucinating, because what you would actually need to determine is that the problem is not sensible. You cannot see what the problem is without making some change. So you need to add more logs, and then when you add more logs, then you can get closer to solving the problem. That's that's one of the like big mid-level to senior sort of mentality shifts that happens with software engineers. That some problems are just not worth analyzing. Just deploy better logs. Like, you don't know what's going on. Okay, just improve observability of the running system. That's point number 2 from today's topic, right? Which is the relationship between ops and dev. Sometimes, yes, you have caused the problem, but you can't point at the line that is defective. You can only look at the working system, and you can only look at the defective output, but you cannot actually, you cannot from the millions of lines of code determine what is causing the problem. So you need to probe. You need to deploy something that will provide telemetry.
This is when you write to your client a WhatsApp message. Can you please share your screen? I don't know what's wrong on your machine.
Yeah, something like that, right? So you're probing. So PSR stands for you probe first.
Yeah.
And then you sense the data, the telemetry that you have probed, and then you respond to the telemetry. So there isn't even a book, right? There isn't a book of possible solutions, because the solution would require that all the logs are known in advance, that all the problem that you go to log in telemetry are known in advance. And if they could have been known in advance, then you would have been logging them. And if you would have been logging them, then it wouldn't have been a complex problem, because somebody else might have predicted it, right? So the aviation industry, for example, all of the bodies of governance that analyze crashes, especially plane crashes with fatalities, they are creating observability in a complex system. That's why we have black boxes, which are orange, by the way, in planes, is in order to make all issues, all incidents probable, so that they can create checklists and basically convert them down into complicated or simple problems. So that if there's an issue, a pilot can just go, okay, we have that problem, that has a solution, we can save everybody, but we need to follow the checklist, right? Like, that's what you're doing. Then there's the chaotic domain. The chaotic domain, the difference between the probing, so A in ASR is act instead of probe. So you can't even probe the system. When you're in a chaotic domain, you cannot add logs because the system itself might not be loggable. So for example, neural networks, how an AI works. I can't add logging to the code because there is no code. It's just a neural network, and the effect is coming from the relationship of data, not of the lines of code. It's not a logic issue. It's like it's the behavior of the entire system with the data. So I can't actually add logs to the system because the system isn't, it isn't linearizable to that degree where I can have like top to bottom, like a trace and a span, and sort of make sense of the system. There might be a lot of simultaneous things going on. So what I have to do is I can only change the system. This happens a lot in medicine. Like, we can't probe the issue. What I can do is I can give you a medicine for the most likely cause. And if it helped, it was that. If it doesn't help, it's something else, but at least it will help us narrow it down. Right? That's why doctors generally don't give you antibiotics, because they don't narrow down the problem enough. Because they might work for a lot of things, but they also might cause issues. And that dichotomy causes practitioners to use it like a more last line of defense. Because what they give you, if there's a better solution, and of course adaptability and all that, but generally it doesn't narrow down the problem enough. So what you would do in a chaotic system is say, well, let's make a change. And then if it worked, then that was the correct solution to the problem. And if it didn't work, then at least we know that that is not the problem and something else is. And most software development, product engineering, product market fit is between chaotic and complex. You cannot ask your customers what they want. You have to deliver something
and see
what happens. That is the chaotic space. That is not complex. That is chaotic, right? You cannot get the correct answer without betting on building something.
Yeah.
Sorry?
The clients themselves don't know it. They think
Of course,
sometimes they know. They
because it
say,
is
"Oh, I would
novel.
like that," but
Yes,
then you deliver it. I don't like that. Why
because
don't you
it
put
is
that?
not a commoditized solutions. By the way, you have this 4-quadrant setup also in like a software space or like a more business, like a canvas space in Wardley mapping. Wardley mapping does basically exactly this, but it breaks down the columns, these like 4 quadrants. I'm always ignoring the middle. The middle bit is confusion. You don't know in which quadrant you are, which is also some softwares, some software engineering teams. But Wardley mapping also has like a great parallel to this. They break down these 4 columns into there's commodity stuff, there's productized stuff, there's custom built, and then there's genesis. Then there's like something that we couldn't possibly have conceived, right? So it's commodity is simple, product is complicated, custom software is complex, and coming up with something like completely novel, like the iPhone for the first time, that is the chaotic space. Customers don't know that they want it until you build it. And even if you talk about building it, they will say, no, I don't want this. But even once you give it to them, it might just have like a natural, like a viral effect. So, for example,
the MVP hunt out there.
Product Hunt is a VC organization like that. Yeah, so they don't know what will be viral, so they just invest a lot of money to figure out like what the market responds to right
By
now.
trial and error, it's basically chaotic. Is trial and error, if you like.
But the key differentiation here is that if you can probe, then probe. If you can just look at it and determine what's wrong, then do that. Right? Like don't run chaotic experiments if the problem is obvious, if you looked. What most software engineering teams are dealing with is that the problem is right in front of them, but they're too afraid to look. They say, oh, I know what the problem is, but nobody wants the solution. And then they treat the system as if it's chaotic or complex because they know what the problem is. You know, I have coaching clients that come to me, engineering leaders, directors of engineering, startup CTOs, and I ask them, what do you think the problem is? Well, we don't have a lot of tests, and releases are very unpredictable, and there's a lot of bugs. And there's a couple team members that don't get along. We haven't been training them a lot. And I'm like, okay, well, why do you need me? You obviously know what the problem is. Well, I don't know how to act on the problem. Well, these things are solved problems. There is best practice for the problems that you're facing.
Well, they are in a chaotic state, and you would, in your head,
they are in a confused state. Yeah, they're in a confused state. So they're in the middle. They're not bottom line.
Yeah.
Right? They just don't know which problems are which. Right?
That's
So,
true.
because they might hear, oh, I think microservices will solve our problems, or I think Git flow will solve our problems. That's confusion. That's the middle. Because they think there's all these solutions, but they just don't know who to trust. That's confusion. Right? Like the big payoff comes when you say, oh, our batch sizes are too large, or our estimates are all over the place. Well, that can be sensed, right? So it's definitely on the right side. It's either complicated or simple because it can be sensed. I can just look at your burn down chart. Sometimes I ask them, completely anonymize, lower the quality. I don't even need to read it. Maybe before we even sign an NDA, just show me the shape of your chart and I will be able to tell you whether this might help or not. The bigger problem is that generally it's very easy to do continuous delivery. It's very easy to do continuous delivery in a team that learns continuously, that has that level of maturity to say, I don't know everything. If it helps, I will try it and I will give it my best. And if it requires some discipline, we will slowly, gradually roll it in. If it's painful or just weird and nobody wants to do it, then we won't. So it's very easy to do continuous delivery in an environment where you also have continuous learning. So it is pairing humility, experience, maturity. Those are the predictors of teams that are doing the right things. And then there's right. So, for example, there was a study, right, about how alcohol is a little bit of alcohol is healthy compared to no alcohol. And you heard about this study?
Well, many people
But
try
like,
to convince me, but
yeah, there was like this study where like one glass of wine is healthy, and
Mhm,
you know
yeah,
that group was healthier than the control group. Well, the issue was it was a downstream consequence of the causality of how the test was conducted, which basically people who can enjoy a glass of wine have more disposable income, and it just happens to be that the people who are well off financially also don't have other issues that come from lack of money, right? Which means that they can probably afford to have a healthier lifestyle. Plus, the people who don't drink alcohol usually abstain because of prior issues, right? So people who abstain from alcohol are people who have issues with alcohol or have medication that requires them not to consume it, or like a weird stressful job where it's not allowed, or right, so or different addictions or other dominant personality types or other comorbidities, right? And you have to analyze the study to understand that, you know what, that's actually bullshit. That's not like the causality loop isn't what the clickbait title would lead you to believe. And it's the same thing here. It's like, yes, if you have a mature team of very experienced engineers, of course continuous delivery will be easy because they're open to making mistakes. They treat each other with respect. The biggest problem is when you don't have that, and there are signs of exhibiting like bad behavior and maybe being a bit toxic and treating like not having that level of like respect, or maybe there is like that I will respect you if you help me before I help you, or this sort of tit for tat mentality of like
enforce reciprocity.
yes, enforced reciprocity or something like that, or it's like very, you know, like that sort of shadow capitalist aspect of, yeah, if it helps me, I will help you, otherwise, like, why are we talking about this, right? So there are organizations. I just saw your message, you have to go.
Yeah.
Okay, so to keep it short, the organizations that are very healthy, like just organizationally, for them it's very easy to do continuous delivery. It is those organizations, and most organizations are not that, because it takes a lot of experience of the right people staying together for the right reason for the right time to create that. So most organizations are not that. The bigger issue is if you're not continuously learning, if your organization is not open to making mistakes, if your organization is not open to experimentation, then you need to become that in an unsafe environment to make any kind of progress, right? Because otherwise you're treating this problem as it's either chaotic and we're just doing weird stuff all the time, or we're pretending it's simple because we basically took all the solutions off the table. So the simple solution is, yes, we know about it, yes, nothing will happen, nobody will do anything about it, so just how it is, you know. And then that level of like giving up, like that level of lethargy, just causes more of this kind of issue, right? So the biggest issue is not what to do if you're a perfect organization. The first step into dealing with these issues is to say, well, if your organization is in this state, what are you going to do about it? What are you going to do to just protect yourself from like that lethargy of the organization? How can you help your team, right? Help yourself, help your team, and then that will sort of bubble forward. But there's no substitute for this. This is just something that over time you'll have to accept
Maybe
as,
my last thing for the conclusion is that what I saw personally is that that's a typical human thing. Things don't change if you don't have a leadership which is willing to bring the change, or push the people towards that change,
yeah,
and or infuse the spark so that of course the people can reach the goals themselves,
yeah.
right?
We're just
But
storytelling. Like just paint a
this is
nice picture.
this is a
Yeah.
narration of the vision, the mission, the goals, define a strategic objective, all these kind of things. You need to incentivize that.
Yeah.
It must be worth following or pursuing setting that goal for the people. If you just tell the people you need to be mature, we can do that without leadership. Well, people don't have an incentive to just become mature. What is mature? What is that goal? How a person that's 22 years old, just finished studies, right, is now in the first job. What is mature? What is the mature way of working of a senior engineer? How shall these people know? Are there enough role models in the team? Most often not. Sometimes you have the role models high above your team. They are staff engineers, principal engineers, those kind of people, or the CTO in a small company.
They got promoted out of the silo. Now they're too far
Exactly,
away
and
from the
then you end up with an intermediate called senior developer, who is not a senior developer yet, is somehow the team lead, but doesn't know it. It's not a pay grade of him. It's just you need to lead them, right? It's or even the funniest thing I was posting about that is the typical the freelancing persons who are hired for a while to lead a team. That doesn't make sense at all. So it's like no. You need to have a leader inside the team for a long amount of time to actually get from A to B. It's take time, right? And those kind of things need to happen. So, and I realized that in your narrative, you changed in the intro. You can see that as well to tech leadership. In the very beginning, when we both met, you were not using the terminology leadership in your coaching. Nowadays, you do. That changed. I just wanted to point that out as an observation of my side. Because it's actually part of that. So as a coach, you are a temporary leader to help a real leader growing actually in the company, in the team, who will then do that long term and introduce the right ground for a new culture which can grow. That is, mindsets which need to be changed. You need to have a common mindset as well. You need to have, cultural requirements. You need to know why you should actually do that. And that is the most interesting and most complicated part, because most people think, look, continuous delivery does work. Why don't you use it? Well, there is so much in between that. It's not just a pipeline. Many people try to reduce that to Jenkins versus GitHub Actions, which is not even close to what that means. It is nothing to do with that. So it is a set of practice mindsets.
That's just the operational part of using the tool that you need buy-in for.
And sometimes you don't even have that. Sometimes you don't have pipelines. You don't need to have a pipeline for continuous delivery in per definition. You should have one in most tech stacks, but there are tech stacks where you don't have that. And so what you actually need is you need to have a mindset shift. You need to learn practices. You need to have an idea of what the team needs to learn. How you collaborate, what ownership is. You need to define. You need to have role models. Part of leadership is my second pillar of leadership is being a role model, right? So you need to know how it actually needs to look like to become, right? So when I'm a junior and I'm supposed to work with full ownership the entire way, going all the way, how does it look like? If no one else practices that in front of me, I cannot expect that this person is able to.
You can't tell your team, hey, this is a problem, figure it out, if you're also punishing and looking for, if you're looking to attribute blame when something goes wrong.
Good. Is good, yeah. Good. So what do we have next week?
I don't think we have anything. I think this is the end of our...
This is the end.
Plan.
This is finish, but not the end.
Yes. So next week, we can probably have a live planning session to plan our summer episodes.
Okay.
That also creates an incentive for you, the viewer, in being very vocal and being very opinionated about what you would like to see in the next 10, 12 weeks of OTJ. If you have any... So this plan was 50-50 AI and continuous delivery. That was the request from the community last time we had this planning session.
I will definitely toss in some more topics around what I do lately. So we are right now still in the release phase, but anyway, it is short before that. And I want to talk a little bit about these things, the experiences together with you. I want to show you some things and talk with you about how you see those things happening as a coach in other companies.
Mhm.
And because the entirety of my type of content and the way I communicate will actually change, because I align to the next SaaS product, which is basically a platform for content creators, coaches, podcasters, and those kind of things, which is based on the big thing we do for companies, for enterprises, basically a B2C product. And that's an interesting part for me, because I was actually never in the B2C space. That's very interesting. So B2B2C, yes, but not B2B, B2C. And I want to talk a little
Not
bit about
D2C,
these
not
5
direct
things.
to customer, but always as a
Exactly.
two-vector
It is
marketplace. Yeah.
always had clients.
Yeah.
Right?
Yeah.
This is the first time we actually serve customers directly.
Mhm.
And that is what I want to talk about more. That is, the challenges, because there are other challenges than actually build B2B software.
Mhm.
That's how you can actually see that. That's one of my things I want to toss in.
Okay.
And why
Looking forward to it.
deliveries?
Yes, looking forward to it. So next week we are having a planning session live on stream. We will be basically opening up our calendar and we will be putting up 10, 11, 12 topics for the next episodes. We will also be having some planning in the vacation times. So Adrian and I usually take some summertime off, a week or two. So we'll also probably discuss like if that's happening, when that's happening, if we already know when that's happening. I already know when that's happening. So we'll probably have to put that, make that part of the schedule.
First year, my son is now 6 years old. So school vacation, school holidays are now a thing for us.
Wow. Okay.
Things change.
That's big.
We need to now spend 3 times more for vacation than last year. That's awful, but yeah, it's
okay. Well, let's discuss that next week. Everybody, thank you for being here. There will be a recording of this coming out to your favorite platforms. There is one already on YouTube. So on YouTube, you can already watch the recording at OTJ. You can find Adrian at Stackable CTO on Substack and Adrian Stanek on LinkedIn. And myself, you can always find on Crafting Tech Teams and Dennis Chakuk on LinkedIn. If you're interested in what it's like running a SaaS company, or if you would like to have some like leadership coaching or engineering practice coaching, reach out to us and see you next time.
Goodbye.
Bye, Adrian.
We need to create an outro, by the way. Don't play the intro.
We need an outro, yeah. I'll just do music for now. So thank you so much.
Okay. Bye-bye.
Putting the background back on, and bye-bye.